exercise 11, we're going to implement rock, paper, scissors. One of the things you like to have is having some randomness, but we don't know how to do that just yet. The book hasn't covered it. So what we're going to do is we're actually going to create a random list, or I'm just going to sort of create a random list, or really a vector, of characters. And we'll call them computer moves. And it's going to be something like this. And it's really totally random, so we'll call it, let's say. Now I want to keep some score. It doesn't matter how many moves there are, and I'll show you why. We'll have some value for int computer score. We'll set it to 0. We'll have int user score. We'll set it to 0. Int current move. We'll set that to 0. That's the current move that we're playing. Car user move. Okay. And what we want to do is we're going to want to print out we want to print out some information. So I'm actually going to pull it out over here, the prompt, and it's going to be void print prompt. And I'm going to say int computer score, user score, and int current move. A bunch of times. So we're gonna go ahead and do it like this. So print prompt, and we're not getting anything back because it's just putting the value out. So with computer score, user score, and current move. And it's going to print this information. Then it's going to wait for the user to put something in. So we're going to go ahead and do standard cin into user move. Okay. And we're going to do like this. While user move is not equal to q, so while a user has not actually said they want to end, we're going to get like this. Car computer move is going to be one of our computer moves. So computer moves at current move modulo computer moves dot size. Now the reason being is that as we're going to be going through this loop, we're going to be incrementing the current move count. And if we get to the end of the list, it's actually going to fall off the list. You'll be able to do that. But this way, we can keep incrementing it, but it's actually going to keep rotating through. So even if you get to like 37, it's going to divide it by computer moves and just the number of moves available and move it back to the beginning. And we can actually go ahead and then just increment over here. We'll see later on that we can actually do it in the code itself, but let's go ahead and just do it like this. And now what we're going to do, the exercise calls us to use a switch statement, so we'll go ahead and do a switch statement. Switch on user move, and we'll do like this. Case rock, if the user has a rock, now we have to determine, so if computer move equals user move, so we know that it's a rock, so we don't do anything, so we'll just say standard cout tie, and we don't do anything. Else, if computer move equals scissors, so we know that rock beats scissors, then we are going to do plus plus user score, and we don't do anything to the computer score. And we'll actually do this standard cout computer played computer move. We can say tie standard cout tie un else plus plus computer score standard cout I win. I'm speeding through this section because it's just fairly repetitive, just doing the same thing for the papers and the scissor case. Now we can just do print prompt, and that is it. And now we can see that the user is going to be able to print prompt multiple times. I'm going to come back in here, and we actually need to read it again. So this was a slight mistake. Computer score, user score, and then current move. Okay, let's make sure and then current move gets incremented. That's right. So actually, let's do that in the bottom here. See in user move. And that should be it. We could probably simplify this switch case. I don't know if I would have done that myself if that wasn't the prompt. But let's go ahead and see if it works. So let's go ahead and run it. And there it is. So it says play your next move, rock, paper, scissors. Let's play with paper. It says computer played R, I win. So right, paper beats rock, correct. Current move count is 0, computer is 0, users 1. So I want to play scissors now. And it says computer played P, and so scissors wins as well. Right, so let's do this one again. Let's do scissors. Computer played scissors. Let's do scissors again. Computer played scissors, 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 scissors. I lost the paper. Let's do rock. Oh, they played rock, rock. So the computer played P, and it wins, I win. And so you can see the computer is rock, played scissors. That's right. Ooh, I'm beating it. Let's see if we can quit. And we quit. Okay, great. So it looks like the program's working. It's doing the right thing. And we can ship it. Now the question becomes, how can we refactor this? Because this is quite repetitive when you have to sort of go through all the permutations. I think there's a good way of refactoring it. But in order to do that, we would likely need to pass around a fair amount of state and be able to do some management, or we can signal back who won, either player 1 or player 2. The challenge is that at the end of the day, even if we did that, if we wrote a method, we would actually have a fair amount of if-else is in here anyway, of saying, you know, if user 1 won or user 0 won, who do we give the accounting to? So although it's not ideal in terms of how this is written, from an efficiency perspective, for this example, this is good enough. So I think we can go ahead and ship this exercise. And this walks through the whole process of creating a rock, paper, scissors game. Hopefully you found this useful.